This QuickLearn Bullet provides an overview of the mechanics and pricing of interest rate forwards. We assume throughout this bullet that bid-offer spreads are zero and that all parties can borrow and invest at the risk-free rate considered to be LIBOR, which is 3% for 3 months and 3.5% for 6 months, respectively. A depositor approaches you on January 1, 2009, asking what rate you would offer her for a 3-month US dollar deposit she expects to place with you in 3 months' time, i.e. from April 1 to July 1, 2009. We assume all relevant days are business days. In the vocabulary of financial markets, we would say that she is asking you for a 3-month forward, 3-month rate, and denote this rate as the 3/6 forward rate. Quoting your customer a forward rate requires that you undertake what is known as a no arbitrage pricing exercise. The process is summarized in the diagram appearing now, which assumes first that you go ahead and borrow funds for 3 months at 3% and invest them for 6 months at 3.5%. We base the calculation on one single notional US dollar, since the specific notional amount does not, in fact, alter the outcome of the calculation. Your investment at the end of 6 months will grow to 1 plus the 6-month interest rate times the actual number of days over 360, i.e. 1.0176, rounded to 4 decimals. The money you have borrowed will grow to 1 plus 3% times the 90 actual days over 360, i.e. 1.0075, at the end of the first 3 months. Assuming you now borrow this amount of 1.0075 again for 3 months, so that now your investment and your borrowing will mature on the same day, you would break even if and only if the borrowing grew over the next 3 months by an amount equal to the ratio shown here of 1.0176 over 1.0075, which turns out to be, rounded to 4 decimals, 1.0100. Since this second period of 3 months contains 91 days exactly, you can solve for the break-even rate you could pay on this secondary borrowing by calculating this quantity here, 1.0100 minus 1 times 360 over 91, which leads to the forward rate being 3.9648%. In effect, the forward rate of 3.9648 is that rate that would make an investor who invests for 6 months achieve exactly the same return as one who invests for 3 months and then again for 3 months at this implied forward rate. This follows from the algebra we used to derive the forward rate. The insight behind the no arbitrage argument can be summarized by writing this equation here, or equivalently, this equation here, where RL is the spot LIBOR for the long period, RS the spot LIBOR for the short period, F the forward LIBOR rate, days L the number of days in the long period, days S number of days in the short period, and of course days F the number of days covered by the forward period. We would use 365 in the appropriate places if the currency is one whose money market calculations are based on actual 365. We have so far described the 3/6 FRA as the rate you would be prepared to pay to your customer on a deposit she places with you starting April 1st. In fact, FRA contracts work a little differently. The bank simply identifies the FRA rate in the confirmation along with the notional amount and agrees in essence that if LIBOR for the period in question turns out to be different from that rate, the bank will settle the FRA in such a manner as to bring the customer back to the rate quoted in the FRA. The customer has no obligation to actually place her funds with the bank itself. She can place them anywhere she likes, hopefully earning the risk-free rate, LIBOR, at least, and the bank quoting the FRA will simply settle that FRA to bring the customer back to the quoted rate all in. Note that in our illustration above, this would mean paying money to the customer under the FRA if the actual rate resets below the FRA rate, but receiving money from the customer if that rate resets above the FRA rate. The end result of all this mathematically is to ensure that the customer has earned on her deposit an annualized rate exactly equal to the 3.9648% that the bank had quoted. This is why a FRA is usually depicted as shown in this diagram about to appear, with a customer receiving LIBOR from the deposit she has placed and in effect paying that LIBOR over to the bank under the FRA while receiving the FRA rate of 3.9648 from the bank and earning all in the FRA rate as becomes obvious from the diagram. We now illustrate all this with an example in which the actual LIBOR rate at the beginning of April has reset at 3.75%, and in which we assume that the client's deposit is for $100. The interest your client would earn on a deposit yielding 3.75% for the period April 1 to June 30 comes to this quantity here, $0.9479. Under the FRA, the bank would also pay to the client an amount equal to this quantity here, which comes to $0.0543. The sum of these two amounts in question gives your customer a total of $1.0022, which is exactly equivalent to an annualized 3.9648% for a 91-day period. There is one last important detail to note about the settlement of the FRA. The bank and its customer will know the level of LIBOR for the second period at the beginning of April, in fact 2 business days before the beginning of April, and so will be able to calculate the amount of the net settlement on that same day. The bank could hold onto those funds and pay them to its customer at the end of the period, which would have the advantage of matching the day on which the customer receives the interest under the deposit, or the bank could simply pay some discounted amount up front to the customer under the FRA. The FRA market has in fact adopted the latter convention, since it reduces the total amount of counterparty and operational risk within the system. So the net payment the bank makes equals the gross amount of 0.0543 previously calculated, but discounted for 91 days at the current LIBOR rate of 3.75%, as shown in this formula here, giving rise to a net PV payment of $0.0538. Assuming the customer can now invest this slightly smaller amount at exactly 3.75% for the next 91 days, the outcome is the same exactly under the two alternatives. We can therefore write the general formula for the settlement payment under a FRA as follows. Notional times the difference between the contract rate and the settlement date, adjusted for the number of days, and then discounted to reflect the early payment of the net settlement. To complete our discussion of FRAs, we provide here the full set of notations for different contracts starting on different future dates. Thus, as you can see, a whole series of FRA contracts for 3-month LIBOR exist, the first of which appears in the second row of this table as the 3x6, relating to the period that starts in 3 months and ends in 6 months, both measured from today. Another contract would start in 6 months and then 9 months, both from today, and would be denoted 6x9 FRA. The contract for the period after that is the 9x12 FRA, and so on, and this process continues. For example, into year 2, where the period starting in 21 months and ending in 24 months would be denoted 21x24 FRA. We illustrate finally how an arbitrageur could make a riskless profit if the bank quoted him a wrong FRA rate, say for the 6-month period. Take the case of a dealer who quotes 4.5% instead of 3.9684% for the 3x6. You now, as the arbitrageur, would borrow at 3.5% for 6 months, invest at 3% for 3 months, and lock in through that dealer the 4.5% investment rate he is offering for the following 3 months. At maturity, your profit per dollar would be 0.00136, calculated exactly as shown here. This may not seem like very much, but please remember that you can implement this very easy trade on very large amounts of money, and that you would be taking very little risk in doing so. Thus, on a $100 million notional, for example, your profit would come to $136,000. The arbitrage also works if the dealer quotes a rate below the correct one. If, for example, the dealer quotes 3.6% on the FRA, you would simply reverse each leg of the trade. So you lend money for 6 months at 3.5%, borrow money for 3 months at 3%, and lock in the 3.6 rate at which you borrow again in 3 months for 3 additional months. This time your profit per dollar at maturity would be 0.00093, or roughly $93,000 for a notional of 100 million. This leads to a final observation regarding the use of the term arbitrage. Even the arbitrages we illustrated in this chapter are not entirely risk-free, although they do come as close to risk-free as you are likely to see. The residual risks are the following: risk of default by the entity or entities to whom you lend the money, risk of default by the FRA counterparty, if and when the FRA is in your favor at settlement. This is another form of credit risk. And finally, the risk that the settlement payment under the FRA, given that it is discounted and paid up front, cannot in fact be reinvested for the duration of the forward period at a rate at least as high as the one used in the discounting process. This completes this quick learn bullet on forward rate agreements.